Alright, we're going to try this one more time. Okay, uh, let's. This video will complete the power schematic. It is a hope that you guys have watched the first video, so let me kind of recenter this a little bit. Alright, we get back, get our pen going. Okay, remember the solar panels are connected to the always-on bus, so when the satellite gets ejected from the P-pod, the solar panels will be exposed to sunlight. When the solar panels start producing voltage, they're connected to this, and this is the always-on bus here. So once the satellite is ejected, this is a mechanical switch. So when the satellite gets kicked out, this separation switch closes. What this will do is this will energize or power up VCC on this chip, which is the watchdog timer chip. When this thing goes high, this reset line will go high. This will power up the always-on bus switched, which will turn on or connect the always-on bus to the unregulated bus, and we've talked about that in previous videos. What that does, the unregulated bus feeds the 3.3 volt bus, and that powers the satellite. So just to kind of get us started is when the solar panels are in sunlight, this always-on bus has voltage on it. When the satellite gets ejected, this switch closes. This energizes this watchdog timer chip, which puts a high on this reset pin, which powers up the satellite. Now, the satellite is in a pretty hostile environment, and it's got radiation, and radiations cause bad things to memory. So if we flip a bit, it's very likely we'll lock up our pick on the CDH. So what we've done is we've built in a little safeguard, and in this line is the watchdog timer input. And what it's expecting here is pulses every 1 second roughly. So as long as the PIC is putting out pulses, this chip holds a high here and everything works fine. If the PIC gets locked up for any reason, the software guys, heaven forbid, didn't do their job well or something, or radiation hits it, these pulses will quit coming. And in about 1500 seconds, this watchdog timer will expire, making this go low. When this goes low, this turns off all of the satellite. Right, we have one other feature in here, and this is called a hard reset from the COM board. So if a touchstone sequence gets put in here, this line goes high. This high pulls this FET low, which pulls this master reset low, which will pull this reset line low, which will power down the satellite. At that time, this thing will get repowered. So this is called the watchdog timer chip. All right, let's move on and get some more circuitry here. We're going to look at this right here. Let me pull this in and get me back to my pen here. All right, here's where that reset switch is coming in. Is that when this is high, this jumper here is in. That puts a high here. This high here is a high side driver, which puts a high here. And remember, this is just a plain old switch where we connect the always-on bus to the unregulated bus. And the unregulated bus now powers up these voltage regulators. So voltage here puts out a constant 3 volts here and a 5 volts over here. So the last piece of this thing, let me go recover my mouse here, is the multiplex piece of this, portion of this. So let me center this up and blow it up a little bit. and recenter it. Okay. And let me go get my pen back. Okay, so what this chip is called a MUX chip. And all it is a series of switches so that we can share our analog inputs. So this goes to the PIC. And I'm drawing the internals of this chip here. And these switches are controlled by the I2C line. In other words, these switches here are connected to the PIC on the I2C bus. So over here are all these analogs, voltages that represent the voltage on the solar panels, or voltages that are proportional to the current flowing on the solar panels, or batteries, or the temperatures. They come in here. All right, and one at a time these get switched on, and this thing comes out and goes to the PIC, A to D. So in a nutshell, I believe we have covered, let me get my deal back here and go, in a nutshell, we have essentially covered the board. Now remember that this thing looks overwhelming. There's a lot of circuitry in here, but most of it is repeated. And of course, this is over here is the PIC, and you guys have messed with the PIC a lot. This thing is the same PIC that you guys have been using, just got more outputs. So basically, you've gotten a quick overview of the power board. So until next time, go build our satellite.